All right, logarithms exam review. These first two, we have, first, this is on the calculator active portion of the exam. So you will be able to check all of your answers using your graphic calculator. You can also expect to see solutions that are in an exact form or approximate form as solutions as you're working through this part. Now, it's going to be easier for you to get to the exact form if you solve the equations like normal. Obviously, you're not going to get to the exact form if you just use your graphic calculator, for example, to graph and find the intersection. But you could absolutely do that and then kind of work backwards. If that's something you're interested in, just see me in class and go over how to double check. Here for these first two, I'm going to use exponent rules because when I'm looking at number 1 and number 2, I'm able to put everything in the same base. For number 1, I'm going to replace 25 with 5 squared. And then I'm going to bring down that 2x. And I'm going to leave the other side the way it is for now. And then power to a power is multiplication. So 2 times 2x is 4x. And now that we have the same base on both sides, we can use the property of equality to cancel our bases and just solve our trinomial. So we have 4x equals x squared minus 12. I'm going to subtract my 4x over, so I'm set equal to 0 so that I can factor. So my solutions, my trinomial is x minus 6x plus 2. My solutions are x equals 6, x equals negative 2. If you put those back in your original problem, put 6 up here in for x, put negative 2 in, you will get both sides of the equation equal to each other. The other thing that you can do to check these again is graph both of these and find the intersection. They would intersect at 2x sides. All right, number 2. Again, we can get this to everything in the same base. I'm going to put everything in base 2. That means my 2 to the x plus 2 is just going to hang out. 8, I can change into base 2. 8 is 2 to the third. And 4, of course, is 2 squared. Power to a power, we multiply. So I'm going to multiply here. Everything else is going to stay the same for now. So it's going to be a negative 3x. And when I have the same base, and I'm multiplying, which is what's happening on this side of the equation, on the left side of the equation, I add my exponents. So I can't drop my bases until I'm down to 1 base on each side. So I got to add my exponents. So this is 2 to the x plus 2 plus negative 3x, or minus 3x, equals 2 squared. And now that I have only 1 base on each side, now I can use the property of equality to cancel them. I'm going to combine my like terms here. Negative 3x plus x is negative 2x. We don't have any squares in this problem, so we can just solve for x like normal. Again, you can plug back in to check in the original problem. Or you can put this in as y1 and this in as y2 and find where they cross, which would be at x equals 0. Find your path of least resistance for these problems. Great. I'm going to do 2 more on this video, 2 more exponential equations. When we look at these next 2 exponential equations, you can see that they do not, we're not going to be able to find the same base. So we are going to have to throw a log at it. The key to number 3 is isolating your exponential. So that's what you always need to do. You always need to isolate your exponential. You can't get to the right answer if you don't. So I'm going to subtract 11 from both sides first. And I'm going to divide by -3. Now my exponential is all by itself. So now is when we introduce a log. I'm going to use natural log since my base is e here. Or since I have the base of my exponential is e. Just remember, when you take the log of one side, you have to take the log of the other. Sometimes we get so excited about being able to use ln, and ln of e is 1, that we skip that step, and then you can't get to the right answer either. So I have 4x ln of e equals ln of 3. And ln of e is 1, so that just 4x times 1 is 4x. ln of 3, remember, is just a number. So there's your final answer in exact form. You will find your approximate solution by putting that in your calculator. Just make sure, if you're not using the fancy fraction, that you close parentheses around your 3 there when you put that in your calculator. All right, and next. Here with number 4, our exponentials are isolated, which is good. It gives us a little less work to do, but we do, and you can use either log or ln here. I'll use log because I think that's what a lot of you would do. So I'm going to take the log of both sides so that I can pull down my exponents. That lets me pull down these exponents. Now it's important, if I have a binomial exponent, to put it in parentheses. So this 3x comes down front, my x minus 1 comes down front, and the 3x doesn't need parentheses, but you better believe the x minus 1 does. And now we can solve for x. So now that everything is on the same level, our game plan from here is to get our x's on the same side, our x terms, and then we're going to need to factor out an x. So our next thing to do is to distribute log of 8. Remember, log of 8 is just a number. It's a nasty decimal, but it's just a number, so we're going to treat it as such. X times log of 8 is x log of 8. -1 times log of 8 is -1 log of 8, or negative log of 8. I'm going to move my x's to the same side of the equation. So that means I'm going to subtract my x log of 8 over. We can't break that pair up yet. They're multiplied, so the only way to break that up is going to be division. And we're going to divide by factoring here in just a second. So the left side of my equation is going to look pretty messy. I have 3x log of 6 minus x log of 8. And that's equal to, careful here that you keep that negative, because that's important, negative log of 8. And if you think that's a mistake that you could make, just stick a -1 in front of there and make sure it comes with it. And here is our key step. Once we have our x's onto the same side of the equation, our two terms have x in common, so we can factor out that x. So now our x is nicely separated. We can divide and do our logarithm rules. At this point, if you would like to do your log rules first, you absolutely can. If you think it would be kind of less messy for you to look at, or you can do your log rules once you move over to the other side. So for your exact form, if you're asked for approximate form on this, you can just put this in the calculator as it sits. Use that fancy fraction button, or you need to have parentheses around your whole denominator here. For our exact, the way I would move this, or the way I would write the solution, I would take this -1 up. So I'd have log of 8 to the -1st power, which is log of 1/8. Then I would take cube my 6. And 6 cubed is 216, if I'm remembering correctly. And then we're going to use our rule for subtraction there. So subtract in logarithm world means divide. That's going to let us write 1 log. And we are going to do 216 divided by 8. And that happens to simplify nicely. 216 divided by 8 is 27. So there's your exact form. You need the logarithm on top and logarithm on the bottom. We do have a rule that subtract means divide, but we don't have a rule for a logarithm divided by a logarithm. There's no way to simplify that. You can use an approximate solution there. All right, those are the exponential equations on your exam review.